as described before, for a general n-shaped function, for example, a minus x squared plus 3x plus 5, that's a general n-shaped function. To the left, we can see, okay, well, there's one thing that that this book didn't do is that the slope is increasing on the way up. That's greater than 0, and after the turning point, it's decreasing. So book made a mistake there. The y dx is greater than 0 on the way up, and it's less than 0 on the way down. This also occurs at the top of it. For a local maximum, your derivative is 0. Why is the derivative 0 at the very top? Slope is going straight across, makes it 0. So guys, if I was to give you a function, okay, and here's the function here, I'd say, let me see, minus x squared, so I just want to do the negative of this one, it's 2x plus 1, take that out. I'll say, so it's going to be minus x squared plus 2x minus 1. If I was to differentiate this, okay, what would happen? If I differentiate it, I get minus 2x plus equals 0. Solve it, and I get minus 2x is equal to 2x equals minus 2x equals plus 1. This means the turning point takes place at x equals 1. Replace x into the original formula, or 1 into the original formula. You're going to get minus 1 squared plus 2 times 1 minus 1. And you're actually going to get y equals 0. So for this question, the maximum turning point is 1, 0. Now, you might be asked to prove, you guys know it's an n-shaper. You guys know this. You might be asked, prove that it's a maximum point and not a minimum point. To do this, differentiate a second time. And when you differentiate a second time, what we get is what? Minus 2. Minus 2 is smaller than 0, hence it is a maximum point. Vice versa, minimum point. Once again, guys, the slope is decreasing for the first derivative and increasing on the way out. Slope is negative on the way in, positive on the way out. Okay? So you're going to get a u-shaped function, and when you get your u-shaped function, what you're going to do is you differentiate once to find it's 0. If it's 0, it's a turning point, and then you find the second derivative, and the second derivative is bigger than 0, it means it's a minimum point. Best way to do this is to get into some questions. Okay? Now, there is one other type of thing. It's what's called the point of inflection. So, remember what I said earlier? Second derivative, if second derivative is bigger than 0, what is it? Minimum. If a second derivative is bigger than 0, what is it? A maximum. Remember what I said? Minimum is... Oh, sorry. Second derivative bigger than 0 is a minimum. Second derivative bigger than 0, or sorry, less than 0, less than 0 is a maximum. If the second derivative equals 0, there is something that's called a point of inflection. This is when the second derivative equals 0. Now look at this function. It's decreasing at the start. Okay, so point of inflection, this is a point at which the curvature of the curve changes. In other words, a point of inflection. A curve stops bending in one direction and starts bending in the other direction. At the point of inflection, the tangent to the curve cuts the curve at that point. Okay, so basically, long story short, guys, you can see that the curve is bending upwards, and then after the point of inflection, it's bending downwards. Vice versa, it's bending upwards, and then on the way out, it's bending downwards. Notice that the curve never stops. In the first one, the curve is continually decreasing. but in the second one the curve is continually increasing. So it's just a change of the curvature as opposed to anything else. Once again, we'll get to know this once we do a couple of diagrams. Okay, long story short, point of inflection, second derivative equals 0. To sum up, it's increasing when the first derivative is bigger than 0, positive slope. It's decreasing when it's negative, decreasing with is a negative slope. Maximum point is when there is no slope and it's a turning point for both of them. But the difference between a maximum and a minimum point is the second derivative is less than 0, and for the minimum point the second derivative is bigger than 0. Point of inflection is where the second derivative equals 0. You need to learn these off by heart. They are not in your tables. Okay? Learn them off by heart. Now, let's do some questions. One from each part. Find the coordinates of the turning point of each of the given functions and determine if each function is a local maximum or a local minimum. Differentiate once. What type of shape is this graph?
Shape.
Which means we're dealing with a maximum. We know this to begin with. Minus 12 minus 4x. Yeah? Then, so when you equal 0, so determine each turning point is a local maximum or local minimum. We're just going to get the second derivative first. What's the second derivative?
4.
Minus 4. And therefore you can say it's a local max. We didn't, however, find the coordinates. The coordinates is the first derivative equals 0. Then we find out that 4x equals minus 12, x equals minus 3. Find the y value. How do we find the y value then? 1 minus 12 times 3 minus 2 times 3 squared. It's going to be minus 36 minus 18. What's minus 36 minus 18? Minus 54 plus 1. Minus 53. Minus 3 minus 53. Will somebody call me out this graph, please? Just the equation of this graph. Anybody? What's y equal to?
1 minus 12x.
1 minus 12x, yeah?
And minus x is 2x squared.
Minus 2x squared. Now, we can obviously see from drawing this graph that the coordinates of the minimum or the maximum. Now, minus 3. It's not 53, I can tell you that much. So,
It wasn't minus 3. It was plus 3.
The first derivative
It was minus 3.
is minus 3. It's minus 3, so that's what happened there. So it's plus 36 minus 18. And what do we get here? 20? 19, sorry. 19. Now guys, drawing the graph, always great for a backup. You can actually see if you're right or wrong. Not necessarily drawing the graph, but putting it into the calculator function, and the calculator function will tell you if you're in the right ballpark or not. So it's great for spotting errors. It's a safety check. Now guys, problem here with these ones. Okay? What you want is, sorry, I'm missing the top of the question. What's the top of the question? I'll get it here, sorry. Sorry? Okay, so, sorry guys, must have just cut the top part out. So, what I want to do is find the coordinates of the local maximum, local minimum point, and the point of inflection of the function. Draw a rough graph of the function. Okay, so here's what we're going to do. We're going to grab one of these ones. I'll do number 6. Okay, number 6. The problem is with this one is, can anybody tell me what shape this is? It's going to be maximum followed by minimum to my knowledge.
Yeah.
Either way, we can figure it out.
That's what it is. It's positive.
Yeah. So differentiate once. And what we get is 3x squared minus 18x plus 15. Solve it equal to 0. When you solve this equal to 0, lads, when you solve this equal to 0, what we're going to get is this. We're going to get, divide by 3, we're going to get x squared minus 6x plus 5 equals 0. Solve it. X minus 5, x minus 1 equals 0. X equals 5, x equals 1. 5 and 1. What I'm going to do next is I'm just going to go straight to my function. I'm going to put this in. Okay. And look at this. X cubed minus 9x squared. I tend to use the function a lot just to verify answers, and it takes very little of my time, and I can tell if I'm right or wrong before I even go. Now, see the way it's 5 and 1? That means I'll probably start off at minus 5 and go to around 10. That way includes 5 and 1. Now look what's happening. It's really, really small. It gets bigger, and then it crosses it goes to 0, 10, 117. What happens in between 1 and 2? Or somewhere in between the 0 to 2 region, it turns around. Keep following it. Minus 10, minus 15, minus 10, minus 15, minus 8. What does that mean? It turned again. The maximum came before the minimum. And we know the points, don't we? We know 5 is minus 15, and we know that 1 is 17. So the answer is 117 and 5 minus 15. We know the answers already for the maximum and minimum turning points. Okay, now we also have to prove that they are the max. That's the max and that's the min. I have to prove it. So look at this, guys. Second derivative is what? What's the second derivative? 6x minus 18. Now, for the 2 points, when x equals 1, what happens? When x equals 1, it's going to be 6 minus 18, which is minus 12. Minus 12 is less than 0. The second derivative is less than 0. That verifies it's a max. Replace in x equals 5. And then what happens? We're going to get 30 minus 18, which is 12. 12 is greater than? Second derivative is greater than 0, which means minimum. Okay. Would you like me to do one more? Alright guys, question 7. Once again, never found the point of inflection. Now, guys, the point of inflection is when the second derivative equals 6x equals 18. Getting ahead of myself. X equals 3. If x equals 3, y equals 1. That saves a bit of time. 3, 1. Look what happens. Will somebody call me out this graph, please? So remember the points 3, 1, 5 minus 15 and 117. Will somebody call me out the equation for this graph, please? Alright guys, call it out to me. What is it? Y equals x cubed, yeah. What's the next part? For question 7? Is it not? Lads, this equation here, please. Question 6, sorry. So what is it?
X cubed minus 9x squared.
Minus 9x squared, yeah.
Plus 15x plus 10.
Plus 15x and? Plus 10. Now look at this, guys. Now, what I'm going to do is I'm going to have to make it go down a little bit. Now, what I really need to do, is I really need to emphasize the difference in the curves. Okay, so I'm just going to drag it out a bit. Now you can see it here. Now look at this. Our first point was, our maximum point was 1.
17.
Our minimum point?
15.
5 minus 15. Now look at the point of inflection when x equals 3, what was it? 3, 1, wasn't it?
Yeah.
3, 1. You can see that it's facing upwards. It's bending upwards here, and then it stops and it starts bending downwards. You can see this point of inflection right here. I might need to just zoom in that bit more on it if you want, really to overemphasize it, and then just give it a bit more.
What exactly is point of inflection? It's where it's
see it's currently bending this way,
yeah,
and now it's bending this way. It's the point at which the curve flattens out from concave up to concave down. Okay? Alright guys, one more for the row, one more here. Now, once again, you got 2 things to do. Part 1, differentiate. So, differentiate question 7, Connor. And we differentiate this, you get 2, you get 0. Minus 3x squared, you get minus 6x. Minus x cubed, you get minus 3x squared. What's this equal to, Patrick? We're looking for a turning point, so what's the rule for that? Do I dx equals 0. Put this equal to 0 and solve. I'm going to multiply both sides by minus, and then I'm going to divide both sides by 3.
Plus 6x. Multiplying it by minus. Plus 6x.
Oh yeah. And then I'm going to factorize x bracket. X plus 2 equals 0. X equals 0 and x equals? Minus 2. At the point this happens, I'm going to go to the calculator. Save myself a bit of time here. 2 minus 3x squared. 3x squared, right? And then I'm going to do minus x cubed. And then upon this, I'm going to go from, I don't know, minus 2 will be included there. Let's say minus 5 up to 10 again. Let's have a look at the function here. It's big, it's coming down, and it hits its minimum because it's going down. Now it's on its way back up. Then it hits its maximum at 0, 2, and now is constantly on its way down for the rest of the question. So we have a lot of information there. We know automatically right away that 0, 2 is the max, and minus 2 is the min. So it's minus 2, and 0, 2. I said that's the min, and this one here is the max, just by looking at it. We now got to prove it. What's the second derivative? Given that this part here is the first derivative.
Minus 6x.
Minus 6x. I got to replace x with 2 values. Got to replace x with 0. So when I replace x with 0, I'm going to get minus 6 times 0.
Okay.
And that's going to be less than 0. Minus 6 less than 0. This verifies that it's a min. Then I'm going to replace it with minus 6 times minus 2 is going to be plus 6 greater than 0, verifies it's a max. As predicted, min and max. You do have to do the second derivative though. Finally, second derivative equals 0 is the what, guys? Point of inflection. And where's the point of inflection then? 6x equals minus 6, x equals minus 1, and then minus 1, 0 is the point of inflection. Okay. Now, that there is the bog standard question. There is nothing tricky there, it's just a procedure. Now, gets into harder. Okay, ready? X squareds have 1 turning point, no points of inflection. X cubes have 2 turning points and 1 point of inflection. X4 has 3 turning points and 2 points of inflection. Now let me explain what's going on here now with 10 part 1. 10 part 1. Verify f of x is 1 local maximum and 2 local minimum points. calculate the coordinates of these points. How would you go about doing that? First derivative equals 4x cubed minus 4x. That equals 0. Factorize. 4x bracket x minus x squared minus 1 equals 0. 4x bracket x plus 1 x minus 1. Where do you get the x plus 1 x minus 1 there? Difference of two squares. X equals 0 for the first one. For the second one, it's going to be x plus 1 equals 0, and for the third one, it's going to be x minus 1 equals 0. X equals 1, x equals minus 1, x equals 0. It wants me to calculate the points, okay? Now, before I do that, I'm going to do the second derivative. What's the second derivative? 12x squared minus 4. I'm going to put in each one of these ones now. Okay? 12 times 0 squared minus 4. Is it bigger than 0 or smaller than 0? That's a max. X equals 0 is a max. Then it's going to be 12 times minus 1 squared minus 4. That's going to be 8, isn't it? Yeah. 8 is bigger than 0. Min. And then finally the last one. 12 times 1 squared minus 4, also 8, bigger than 0. Therefore it's a min. Have I verified that's 2 maxes and 2 mins? Yeah. I have. I'll say 1 max and 2 mins. Calculate the coordinates of this point. Do you know what, lads? Sooner let the calculator do it. Okay?
You're using your gun.
Yeah. I'll verify that anyway with the marking scheme, but there's no reason, if they give you this capability and they're pushing this calculator, there's no reason why you shouldn't be able to do that. Okay, so x power 4 minus 2x squared. And how far do you think I need to go? 0, minus 1 and 1. So look, it's captured in all the points there. So it's going to be 0, 0, 0, minus 1, minus 1, and 1, minus 1. Okay, so it's 0, 0 is the max, minus 1 is a min, and 1 minus 1 is also a min. Perfect. Find the coordinates of the 2 points of inflection. How do I find the 2 points of inflection again, guys? The second derivative equals? Perfect. Now I'm going to factorize out 4 into 3x squared minus 1 equals 0. 3x squared minus 1 equals 0. X squared equals a third. You happy with that? And what's x going to equal? Sorry? X is going to equal square root of a third. Plus or minus the square root of a third, lads. So x is going to equal plus 1 over root 3, or x equals minus 1 over root 3. Now if you wonder where I got that from, square root of 1 over square root of 3 is square root of 1 over root 3. Root 1 is 1. Now, unfortunately for us, I got to put this into the original equation to calculate what it is. So I actually have to put it back into x4. What's x4 minus 2x squared? I actually have to put it in here and figure out what it is. So y is going to be equal to 1 over root 3 to the power of 4 minus 2 times 1 over root 3 to the power of 2. That's going to turn out to be, guys, is it's going to be a ninth minus 2/3. And what's a ninth minus 2/3? Minus 5 over 9. So this point here is going to be 1 over root 3 minus 5 over 9. And lucky for me, the other equation turns out to be exactly the same. Because to the power of 4 means it's a positive number, to the power of 2 means it's a positive number. That's also minus 5 over 9. Alright.